Let's look at an application of using a determinant of a matrix. So one of the best examples of an application is to solve a system of equations with Cramer's law. So if we look at a system of linear equations, for instance 2x minus y equals 4 and x plus 3y equals minus 5. So we want to solve this equation, so we need to determine what is x and what is y. Okay, to solve this equation using Cramer's law, what we need to do is we need to break the system of equations into matrix form. So let's see how to convert this to matrix form. So what we need to do is we need to take the coefficients of the x and the y variables. So it's going to be 2x minus y, so it's minus 1, and x plus 3. So this is the matrix of the coefficients. And then we multiply it by the variables, so it's going to be x and y. And then we say this is equal to the answer, which is 5 and minus 5, which is another matrix. So for Cramer's law to work, we need to get it in the form AB equals, AXI equals B, where A is the matrix of the coefficients, xi is like x1, x2, or xy, which is the variables, and B is the answer of the equation. So now we've got it in matrix form. The next step, what we need to do is we need to get the determinant of A. So if we look at the equation of Cramer's law, it says that x would be the determinant of ax divided by the determinant of A, and y will be the determinant of ay divided by the determinant of A. Okay, so let's take, so the A matrix will always be the coefficients matrix. So we're going to say A, we need to find the determinant of A for the top part there, of the bottom part there, and that would be the determinant of 2 minus 1, 1 and 3. Okay, so the calculation here is similar to what we've done for the normal determinant. So it's going to be 2, we need to multiply 2 with 3, which is 6, minus 1 multiplied by minus 1, which is minus 1, 6 minus 1 is 6 plus 1 is 7. So the determinant of A is 7. Next we need to get the determinant of AX. So to get the AX matrix, we basically take the A matrix and we substitute the X. So we're working with X, so we look at the X coefficients, which is the 2 and the 1, and we substitute it by the 4 and the minus 1, minus 4 and the minus 5. So we're going to take 4 and minus 5 instead of the X values, and then we're going to, the Y coefficient stays the same. So we're just substituting the X column with the answer column, so which is 4 and minus 5. And then we get the determinant here, so 4 multiplied by 3 is 12, minus 5 multiplied by minus 1 is minus plus 5. So it's going to be 12 minus 5, which is 7. So now we've got the determinant of AX, which is 7, and the determinant of A, which is 7. 7 divided by 7 is 1. So that's the answer of our equation. So now we also need to determine the determinant of AY. So just like with the X values is now the same. And now we substitute the Y coefficients with the answer column. So the Y coefficients in this case is minus 1, 3. We're going to substitute it with 4, and minus 5. So you can see the y column now is substituted with the answer, and we get the determinant. So 2 multiplied by 10, 5 is minus 10, minus, and then 1 multiplied by 4 is 4. So minus 10 minus 4 is minus 14. Okay, so now we can get the y is then the determinant of ay, which is minus 14, divided by the determinant of a, which is 7. So y is going to be minus 2. And this is how we use Cramer's law to solve a 2 by 2 equation. So to solve the equations, we always need 2 equations to solve 2 variables. So in the next video, we will look at how to solve a 3 by 3 matrix with Cramer's law.